Hello, everyone. Thanks for joining our webinar today. This is Unveiling Kubecost 2.0. We'll be walking through our newest release and showcasing all the new features. Our speakers today are Kai Wambacher. He is our product manager here at Kubecost, and Sean Pomeroy, our solutions engineer. Just to give you a heads up, we will be recording the session today. So if you cannot stay for all of it or want to forward it to someone else on your team, we will send a recording out of it after the fact. We also received quite a lot of questions pre-submitted, but you're also welcome to submit questions throughout the duration of the webinar, and we'll save some time at the end for a Q&A. We won't have time to cover all the questions, unfortunately, but we are developing a blog post to cover all the questions that we are unable to answer, and we can also set up any time with folks that want to dive in specifically with Kai and Sean to learn more about the tool and your personal use case. So with that, I'll go ahead and kick it off over to the team.
Thanks for joining, everyone. I'll start us off with just a quick agenda of what we've got going here. For starters, we'll do a brief introduction of Kubecost and our company and product, and then we'll talk a little bit about why we've decided to develop Kubecost 2.0 or what motivated us to do so. We'll spend the majority of time today, though, in a hands-on demo showing off the newest features, and then we'll leave about 10 minutes at the end for any questions. A little bit about Kubecost to just start us off. So we started as a company in early 2019, and we started as really an open source tool to give developers visibility into their Kubernetes spend. And today we've grown to help thousands of teams of all different sizes, help them monitor their Kubernetes and cloud spend while reducing waste and balancing cost against performance and reliability. So whether you're using AWS, Azure, GCP, or on-prem or some sort of hybrid approach, Kubecost is able to give you a single pane of glass into your costs and help you make educated business decisions that you can feel confident in. As a product, we are already managing over $3 billion in cloud spend, and we have leading companies like Adobe, Audi, and Snowflake all using Kubecost to untangle their cloud bills. And they're also taking advantage of our incredibly valuable optimization opportunities to help their teams, be accountable and develop a culture of cost awareness that, really, helps them save money. So enough about us. Let's dive into Kubecost 2.0. So, when we think about why we started development on Kubecost 2.0, it really comes down to a couple these kind of core issues that we were seeing in the market. So number one, we were seeing rapid growth of Kubernetes environments. What was a large environment, maybe a couple years ago is now like a small to medium-sized environment. So we've invested a lot in helping Kubecost become more scalable to grow to these Kubernetes environments of massive size. We've also heard a lot from teams that they want to be able to run their kind of show back or charge back use cases with not just Kubernetes costs, but with all of their cloud spend. And they want kind of one tool or one pane of glass to help facilitate that. We also heard from a lot of customers where their network costs were a big black box for them, and they were unable to really understand what was driving their network costs. We actually worked with some customers who saw a 30 times increase in network costs, and it took them weeks to be able to untangle where that spike in costs were coming from, just because they didn't have any visibility into it. So, Kubecost 2.0 is made big strides there as well. We are also, a lot of the teams wanted some simple automation. If you're familiar with the Kubecost 1.0 versions, we had some savings insights to help, you identify inefficiencies in your environments. And now we're going to be delivering just simple automation to help you actually take advantage of those insights. And then finally, a lot of teams are looking, once I have my costs, monitored, and once I've started to optimize my environments, I really want to take that a step further and start governing my spend going forward so I can ensure that the efficiencies I've gained are maintained. So we've invested a lot more to help teams, govern their spend as well. Next slide. So when we think about our product, we generally break it down into 4 themes, and we'll kind of present the 2.0 features as part of these themes. So number 1, observability or cost monitoring. This was really the backbone or foundation of our entire product and kind of how we started. And we want to continue to invest more here to be a world-class solution for cost monitoring. As I mentioned, we also have operability, which is really, extending our observability to ensure Kubecost can, run smoothly for customers at any scale. Building on top of that, we have optimization to help teams make their environments more efficient and save money. And then finally, as I mentioned, governance to put guardrails in place to maintain their efficiencies going forward. So the first big 2.0 feature we have is in our operability theme, and it's really an entirely new API backend that we're calling Kubecost Aggregator. So this entire new API backend for Kubecost is really what's unlocked a lot of these other features that probably were not possible under the old architecture. So this new API backend, we've seen it scale to environments of 100 times the size of where we could previously scale. Really teams running millions of unique pods per day are now able to have a very smooth, performant, efficient with the Kubecost product. So we've seen massive improvements in terms of scale and performance on the product. We've also seen significant reductions in the cost of running the Kubecost application itself. So because we've introduced a database layer into the architecture, now the Kubecost application doesn't have to hold all of your data in memory, meaning you don't have to provision as much RAM to the Kubecost application. And again, the cost of running Kubecost itself is significantly reduced. And then finally, because of these performance gains that this architecture has delivered, teams are now able to query more data. So for instance, in Kubecost 1.0 versions, if you would go to query 3+ years of data, it would either take a really long time to return that request, or it would just give you an out-of-memory error altogether. So with this new architecture, you're now able to say, like, I want to understand my Q4 cost for this namespace from Q4 21, Q4 22, and Q4 23. You're now able to do much more kind of historical and maybe finance team oriented reporting. And finally, we've also gained some usability improvements for filtering and aggregation as a result of this new architecture that Sean will highlight here.
Awesome.
So yeah, Sean, you want to highlight some of these new additions or how impactful?
Yeah, let's go ahead and dive right into the product and talk about how the new backend kind of helps the performance and scalability of our product. So starting with this allocations view. So those that are familiar with Kubecost, know this is like the one-stop shop for understanding your costs within a Kubernetes environment. And for those that maybe not familiar with, I'll talk about some of the high-level features here as well. So like Kai was saying, the big thing is being able to look at a wide range of data fairly quickly within the UI. You can see it renders very quick based on the previous performance of the application. From this view, we can see a number of different cost details about our different workloads running across multiple clusters and multiple cloud environments. The autocomplete feature is a really nice addition here. We've also moved the filter UI to its own dedicated dropdown. So if I very simply want to focus on certain environments or certain areas, I can very quickly filter on these different environments. So I can see I just filtered down to my production cluster. So now all these namespaces are the ones that are running on that particular cluster. And let's say we want to focus on a specific namespace. We can come in here, get that list of dropdown, look through all the different namespaces we have, and select the one that we want to focus our efforts on. From here, we're now following the Kubernetes hierarchy. So if I'm starting at namespace, I can go ahead and drill into this Acme Fitness namespace. I can see all of my different controllers running within that namespace. So my deployments, my daemon sets, my replica sets, so on and so forth. I can drill in to one of those deployments in this case and see all the different pods that have run over the given period of time. And finally, clicking into a pod is going to bring me into the container level view. So this is essentially going to show me the breakdown of cost based on how Kubecost is calculating them. To do that, we use 3 sources of information. So the first is the underlying node cost. So we're pulling in the billing data from your providers to understand what you're being charged for a node. And that will also include any discount mechanisms that provider may have afforded to you, whether it be a discount you purchased via like savings plans or RIs, spot node usage for those more ephemeral volumes types. And then, of course, if you have a negotiated discount with the provider themselves, that will be reflected here also. Then we're capturing the runtime, so how long that given container has run over the given window. So we can see 800 plus hours here over the last 90 days. And then ultimately looking at the combination of the requests versus the actual consumption, and then taking the maximum of that. So if a container is using more than its requested capacity, we're calculating the cost based on the actual consumption. And then if a container is using less than the requested capacity, we're calculating based on the requested capacity for that particular container. All right, so kick it back over to you.
Yeah. So that's again our new Kubecost aggregator backend feature that's unlocked a lot of these new observability features. So number one, I'm super excited to introduce Kubecost collections. So the use case here really is to give teams a single pane of glass where they can view their costs by, application, by team, by department or project, however you want to break it down. And it can contain both Kubernetes and cloud costs. And those costs, as you add them to your collection, are going to be deduplicated. What does that mean? It means that if I add, let's say, if I'm creating a collection for my data science team, I can add in my data science namespace, and then maybe I want to add some cloud costs to my data science team name collection as well. I can add, all cloud costs where, custom label team is data science. Well, it's possible that the EC2 instance running the data science namespace is also tagged with that data science team. So in that way, you would kind of be double counting costs. So Kubecost is going to automatically deduplicate those costs for you so that the total cost you see for your application or team or project is going to be the kind of true total cost. So yeah, Sean, I don't know if you can give everybody a sneak peek of this. Yeah.
Perfect. Yeah, thanks, Kai. So this is actually one of the features I am most excited about, having a background in FinOps and in cloud cost optimization. I feel there's a real need for essentially combining the costs between Kubernetes and cloud. So that's essentially one of the focuses of this collection. Now, those that are familiar with the Kubecost interface will recognize our aggregation dropdown. So we can aggregate by an individual collection, but we also have the concept of a category, basically, so you can assign different collections to a category, which gives you a bit of a hierarchy to the different collections that you might have. Think of a situation where you've got a cost center, and then within that cost center, you've got maybe applications, teams, different projects and such. So you can essentially add it to that specific cost center as a category, and then you can add your underlying collections there. So if I actually switch to this category view, you'll see that all the applications I had defined now collapse under this application collection. And if I drill into this application, you'll see that collection that category contains 3 collections, one of Grafana, one of Kubecost, one of Acme Fitness. And we can also see we have some overlap here. If we wanted to say update one, we can go ahead and click into this Acme Fitness collection. We can see the rules that are associating costs as collection. So the first one is a Kubernetes rule, which is essentially saying any costs related to the Acme Fitness namespace will be included in this collection. And then additionally, we're saying that the specific AWS S3 bucket called KCDemo ETL2 will also be included in this collection. If we wanted to add a cost, we can very simply click the link down the bottom here. We'll be brought to the new cost not in collection UI element, which will basically give you the ability to select your costs. So from here, I can pick my Kubernetes domain, which will allow me to pick basically any one of those Kubernetes concepts that we had on the other screen there. So I can pick a different namespace. For this example, I'm actually going to choose cloud to see all my cloud costs. Right now, we're aggregating by service. But let's say I want to aggregate by my owner label. We see our autocomplete in play there as well. So now all of our costs here are reflective of the value of that owner label. So basically like owner equals sales. So I can go ahead and select the sales item here, which will then go ahead and bring my costs into that collection. So if I go back to cost and collection and drill back into that Acme Fitness, we'll now see that we're including the cloud costs related to owner equals sales. And we'll also notice that we've gained some overlap here. So basically what that's saying is that there are some resources associated to this cloud-based tag that are actually running our cluster, right? So likely some EC2 spend in there.
Awesome. Yeah. So that's what we've heard from our customers, that's unlocking a lot of chargeback or showback use cases for FinOps teams. So thanks, John. Next feature, advanced network monitoring. So as I mentioned, for a lot of teams, their networking costs were a total black box. And so this is really here to help teams, especially like large teams with complex, maybe multi-zone environment or networking setups. Like this is really to help teams unpack where are their network costs coming from to help teams understand, how they can make their setup more efficient. So Sean, let's show our, brand new UI for this.
Yeah, so this is supported based on our network cost daemon set that many of our customers are already running. So basically in cluster monitoring the traffic flowing in and out to your different resources. This adds a new visual representation, a layer that you can essentially interact with to better understand your data transfer. You'll notice a few different elements here. The first being the blue icons. So those are in this case are signifying the namespace or the aggregation that I'm currently using. The green boxes indicate cloud-based services. So we can see we've got some Azure storage going on. We've got some GCP services. We've got some AWS services as well. And then the lines or the arrows between those boxes essentially are indicating the data transfer. So internal or external to the cluster. And then you'll also notice that some of the lines change in thickness. Like we see this Thanos one, a fairly large line here going to S3. So that's indicating obviously more cost. So those lines are proportional to the cost of that data transfer. From here, we can filter just like all of our other resources. So say I want to focus on that production cluster, like we showed in the other examples. I can now see all the network transfer related to here. Let's pick on Thanos because of that heavy line there. We clicked on Thanos and then essentially drill into the details. So now we can see that Thanos is communicating with EC2 as well as the S3 services. We can see the cost related to that data transfer in the table down below. So we can see that the Thanos namespace actually consumed a fairly large amount of cost over the past period of time. And that's actually something we'll focus on in a session further on in the webinar today. So we can basically help troubleshoot those costs and drill a bit into where they're coming from.
Awesome. Yeah, and I guess the last, big enhancement we have under observability is improvements to our real-time cost estimation. So if you're familiar with how Kubecost works, we monitor, and Sean touched on this a little bit earlier, but we monitor your usage in real time. And then we use the publicly available cloud APIs to associate a cost with that usage. So if your namespace is running on an N2XL node, and it's using X amount of CPU and Y amount of RAM, we kind of monitor that usage in real time and then look up the cost of that node using the publicly available APIs to assign a cost. However, a lot of teams have, some sort of, EDP agreement, savings agreement with their cloud provider, or they have maybe are taking advantage of RIs or spot instances. So they actually are maybe paying less than what Kubecost is estimating. So we run a process called reconciliation roughly about every 48 hours when your cloud provider updates your bill to reconcile the costs that you're actually paying to your cloud provider so that all the costs from your bill are accurately reflected in Kubecost. So you can kind of see here in the graph, the last 48 hours, the last 2 days have this kind of candy stripe effect to indicate that there are unreconciled costs in that time frame. One of the enhancements we've made in 2.0, however, is we are going to be learning now from this reconciliation process. So if some specific node type has, let's say, a standard 10% discount applied because maybe you have RIs purchased for that node, though we are going to learn that discount and then use that new price in our real-time estimation so that the delta between your reconciled and unreconciled costs is significantly reduced, and maybe even zero if the savings you're taking advantage of are pretty consistent. So, this is going to be mostly, especially impactful for larger organizations who, may have pretty substantial savings with their cloud provider. Yep, so those are the big observability enhancements coming in Kubecost 2.0. So building on top of that now, getting into optimization, we touched on this a little bit earlier, but we're now launching Kubecost Actions, which is kind of taking our savings insights a step further and really giving teams, the ability to, with the click of a button, set up some pretty simple automation to start saving money. So we're launching 3 actions here: cluster turndown, namespace turndown, and automated request sizing. So cluster and namespace turndown allow teams to really say, hey, like this development cluster or this development namespace, I don't need it to be running at nights from 11 p.m. to 5 a.m. because nobody's using that. So why keep those resources up and running? And I'm continuing to pay for it when nobody's using those resources. Or maybe on Saturdays and Sundays, we want to turn it off as well if it's a development cluster nobody's using, but you're still paying for it. And then similarly, you have your automated request sizing, which is really, if you're familiar with our request sizing page, maybe we can show that, Sean. If you're familiar with our request sizing page, it's basically giving teams the ability to, just with the click of a button, actually implement the Kubecost recommendations for the request size of the container. So again, if you're familiar with this page, we look at your average and max usage, where you can see here, and of both CPU and RAM. And then we say, okay, you can configure this so it has, let's say 20% headroom or more. We recommend 20% headroom for development environments. So you can see where we have let's take an example here where the second row, Kubecost forecasting, it's using a max of 128 millicores, right? But you're requesting 300 millicores. That's a lot of wasted or unused resources. We recommend setting the request at 159. So this new Kubecost action is going to give you the ability with a simple click to actually implement the Kubecost recommendations. And I think Sean's going to walk us through this.
Yeah. So to build on top of that, that's like your one-click resizing event. The actions would actually help you automate that as well. So the automated request sizing can be set on a regular cadence, so daily, weekly, monthly, or quarterly, and you can set a start date as well. So if you have like a scaling event that you're expecting in the future, maybe you host some shopping application and Black Friday's coming up, you can basically pre-plan or pre-schedule this automation as well. You can define the look back window, so basically the previous period of usage to analyze in order to generate the recommendation and ultimately the sizing requests, as well as that targeted efficiency that Kai was talking about with regards to this profile. And then, of course, you can customize that based on how you see fit here. Oops, looks like demo gods are not happy. There we go. And then additionally, you can add the same filters that we had in the other view. So I can filter down to a specific cluster, or I can target a specific namespace, and then we're going to give you an example of what is going to happen down below. So basically the targeted workloads as well as the projected savings by making those changes. And then additionally, the namespace turndown, super helpful for like dev sandbox environments, right? You don't necessarily need to have them running over the weekends or over holidays. So here you can essentially define what type of schedule you want to follow, whether it be based on time or smart scheduling. So smart scheduling actually uses our abandoned workload workflow, basically to understand which workloads are not currently being used based on network transfer. And then you can set the schedule currently based on cron, but we'll have a regular like window selector here in an upcoming release. And then if there's any particular like namespaces or resources based on labels that you want to ignore and not have turned down, you can add those exceptions here as well.
Awesome. Yeah, so this is our new optimization solution, Kubecost Actions. And then finally here we have our new governance features. So really these two kind of tie in together. We have forecasting, which is we actually have a machine learning model powering this forecasting solution, which is going to be deployed in the customer environment. And it's going to learn from your historical spend. It's going to learn any patterns, if you have, let's say, increased spend in a specific namespace on Mondays or, at the first of the month. It's going to learn any patterns in your spend and then use those patterns to project, we think you're going to spend, X amount over the next 7 days, 30 days, 60 days. So really helping teams, get their hands around planning and budgeting. And this ties nicely into the Kubecost budgets functionality, where you can use this forecasting feature to say, hey, this specific namespace is projected to spend, maybe $300 over the next month. We want to set a budget accordingly. And this forecasting model is going to run on literally any entity. So, all the way down, to the container level for Kubernetes or, individual cloud resources. You're going to be able to forecast spend, on any entity or any set of entities that you like. And then building on top of that, right, we have our anomaly detection, new anomaly detection functionality, which is going to say, hey, look, if your spend is, a standard deviation or 2 standard deviation outside of what we expect, then we're going to flag that as an anomaly so that you can really, get ahead of any, issues with your spend or any kind of like spikes or unexpected spikes in your spend. You're now going to be able to see that in your anomaly detection page.
All right, so let's go ahead and see what some of those new features look like. So I'll use the same allocations view that we had before. Currently looking at the last 7 days, you'll notice this little green dot on the edit button. That's to indicate that there is a new feature here. Same with those, new tags on the navigation on the left-hand side. From the chart drop down, you'll see a new core cost forecast item. When we select that, you'll see the graph now changes at the top of the page to 2 basically different windows. So we see realized spend. So that's that last 7 days I selected. Maybe we want to choose a bit wider of a time period to analyze. So pump it up to the last 30 days spend. And then we'll see also projected spend, right? So I'm looking at the next 30 days, and you can bump it up to 60 days as well if you like. This will learn over time because it is basically based on machine learning. So as we learn more about your workloads, the confidence interval will basically get tighter as we understand what you're actually consuming. And then you'll also notice down below that the total line item will now essentially indicate the high water mark of the projected spend as well as the low water mark, and then the trending cost for those particular workloads. As Kai was saying, this applies to the allocations view as well as the assets view. So we'll have that same cost forecasting available here, and then also the cloud costs. So it's not specific to Kubernetes workloads. You can essentially use the forecasting to understand the projected spend based on any of the workloads that Kubecost is currently monitoring. And then for the anomaly detection, so earlier in the webinar, I said, focusing on that Thanos data transfer cost. So I'm actually going to use anomaly detection to understand that discrepancy in our costs and that new found spend there. So we'll notice that EC2 specifically, the cost has risen dramatically, up over 84% over the last 30 days. If I go ahead and click on this EC2 line item, it's going to bring us to our Cloud Cost Explorer. We can see our costs related there. I'm going to go ahead and look back over the last 7 days. That's a little bit self-serving there because I know when the action actually happened. So we can see 2/9/2/10. Actually, maybe bump that up to the last 30 days here. We'll see the progression over time, right? We see that on the 9th and the 10th, that cost jumped up dramatically. If I go ahead and click into this EC2 line item, we're now going to get to our resource level view. I'm going to go ahead and sort by cost here to see which items we have here. Specifically, I know that the NAT gateway was one of the offenders, and we can see that even though these are EC2 costs, the NAT gateway cost appears very close to the top when summed, or rather when sorted by totals. So if I click in here, we can actually see that NAT gateway cost exploded over that same time frame, which was actually related to that Thanos data transfer to S3 in AWS.
Awesome. Yeah. So this is a little, peek into all the, new features we have coming up in 2.0. I see we got a lot of questions, and I know we, had a bunch pre-submitted. So I'll start us off if that's okay with some of the pre-submitted questions, and we'll try and get to as many as we can with 30-ish minutes remaining. So yeah, first question want to start us off with is, curious. We have a user who's curious to see if Kubecost covers complex models that allow us to set different prices to different hardware, for example, CPU models, GPU types. Is that something you can talk to, Sean?
Yeah, so we actually offered, in fact, pull up my doc site here real quick and show you some additional information here. We also offer a custom pricing model. So if you don't want to use the cloud provider pricing, or if you are working on-prem, you want to define a custom price list, we do provide the facility to define like a CSV price list, and you can price resources based on like if you have the concept like an instance type or a node type on-prem or even in the cloud, as well as like storage costs. But then we've also added the ability to define like specific GPU types. So if you're using like your A100s or something in your on-prem data center, you can basically add a per GPU cost, and that's going to be for like each vendor type of GPU as well.
Awesome. Yeah, thanks for sharing, Sean. We also got a ton of questions around, is this functionality going to be available in the free tier of Kubecost or the EKS optimized tier of Kubecost? I'm excited to announce that we are going to be providing this functionality in the free tier of Kubecost. It will be come along with a scale limit of up to 250 cores. So you'll be able to use this Kubecost and this functionality in Kubecost free and really start to try it out and get a feel for it, and provide us any feedback or questions that you may have along those lines. Awesome. Another question is, how does the deployment method of Kubecost 2.0 compare to the 1.x versions? Sean, is that something you could talk to for us?
Yeah, great question. So we've got a number of different articles in our doc site here. So specifically, we've got like a Kubecost 2.0 install upgrade article to link to from the main page as well. And it will be in the blog post that we'll have launched here shortly. Essentially for single cluster users, so that's going to be basically like our free tier users, Helm upgrade. There's nothing really beyond running a Helm upgrade, just the new version. We've taken a lot of the logic in the Helm chart itself to make sure that everything is managed appropriately. For those on the enterprise offering or paid customers, there are a few migration steps required if you're using Thanos or federated ETL, but this doc should walk you through it. It's pretty straightforward. We just did it to our demo environment last week in preparation for this webinar. And then, of course, your success team can help you with that migration as well.
Awesome. Thanks, Sean. We also definitely got some questions around, for those of you who are familiar, what we just demoed here is 2.0, our 2.0 functionality in the Kubecost self-hosted product. We do also offer a SaaS product. So we got some questions around, when will these features be brought to the SaaS product? Again, happy to share that a lot of these features are going to be quickly added to the SaaS product. I can say that the collections feature that we demoed is already in the staging environment of our SaaS product. So these will be a fast follow and coming soon to the cloud product. Awesome. I'm seeing some questions in the chat as well. Sean, can we also see an example of aggregating the allocations page by a label and showing 90 days or more? And this is definitely, a core use case of ours where, you can filter and aggregate by any kind of label you want here. So you can see here, Sean's going to aggregate by owners, and you can see we're going to show less 90 or 60 days of costs, by owner. But again, any kind of custom label you have here, you can do filter or aggregation by in Kubecost.
I got an app label as well.
App, yeah. Awesome. We have another question here about any improvement or development on Windows containers. Sean, is that something you can touch on?
Yep. Yeah. So the Windows support hasn't changed much. We actually have a dedicated article on it. We can run in Windows Kubernetes clusters. There is a requirement to have basically a Linux node to run the Kubecost workloads. There are some caveats about what's available, and that's mostly because certain metrics that we need to calculate the cost are not available on Windows nodes because the downstream metrics, basically CAdvisor, I believe, is not available for there. It might have been KSM metrics. I'd have to look it up to recall specifically. But there is basic functionality for Windows nodes so long as you do have some Linux nodes available in that same cluster.
Awesome. Thank you, Sean. Just continuing with the questions here. Let me see.
I see a licensing question
Yeah,
at the top there.
Yeah.
Yeah, from a licensing perspective, if you were to purchase Kubecost, there's no restriction on what account you can run it in. Basically, you can run it absolutely anywhere pursuant to what the license says for like a node count.
Awesome. What is your mechanism that you would use, that you would recommend to right-size CPU and memory? We had some issues while blindly following the recommendation. Sean, is that something you can speak to?
Yeah, cluster sizing is tough. Probably a good one for a follow-up blog post. We do some basic calculations based on bin packing of your workloads and what we understand of your workloads. But obviously different cloud providers, different environments have different limitations, around like networking or volume attachments. So it's more like a checkpoint, and you can use that information to make a more informed decision about like what instance sizes you can run.
Yeah, I think this may have been related to the recommendations for request sizing as well. So in that case, we would recommend, expanding the window if you're seeing issues with, the recommendations coming out of Kubecost for that.
Yep. And that's also a good call out for the actions, right? So if you just do like right sizing isn't typically a one-time thing, right? You have to continuously right size your applications as you develop them, as you add more functionality, as you onboard additional customers, as you do more work. And that's where the automated actions can come in handy, because they're essentially targeting an efficiency, right? So instead of just buying into like this is the CPU memory I need, you say this is the efficiency I'm looking for, and then the Kubecost cluster controller will automatically scale it based on that targeted efficiency.
Absolutely. And I think we had another question further down about how this works with Carpenter. We have a lot of teams who use this with Carpenter, so that the Kubecost action resizes the container request, and then Carpenter kind of comes in over top and resizes the nodes themselves to actually execute those savings. So we see a lot of teams using them successfully in tandem.
Cool. I see a question here from Kyle with regards to like configuring the different components of Kubecost. There are backing APIs for everything, and then additionally, our Helm chart is pretty robust. So basically, you can like predefine those actions or reports or different configuration items in Helm as well. So if you prefer to take a more GitOps approach, we definitely support that.
Absolutely. Cool. What is the difference between the saving action that uses cluster controller and Carpenter? Oh, I think I just touched on this. So yes, no, these can be totally used in conjunction with Carpenter. We've seen many cases where that has worked very successfully. Is governance only for Kubernetes clusters, or can it also help custom governance on third-party vendors like Splunk or Chronosphere? That's a great question. I would say it is something in our product roadmap for 2024 to bring in costs and optimization and governance for more external or third-party services like a Snowflake or a Splunk or a Datadog. So more coming here this year. Maybe for Kubecost 3.0 we'll have some pretty cool functionality for that. Sean, you want to take this next one?
The marketplace one, yeah. So that's a great call out for the marketplace. We just checked up on that the other day. So AWS actually manages the marketplace add-on. So we're working hand in hand with that team to get that updated to 2.0 shortly here. We did a Containers on the Couch episode earlier this week where we mentioned the same. So keep an eye out. We should have that released very shortly. Maybe we can send you an email when that's around as well if you want to post your information.
Awesome. Yeah, Marco, can usage and cost be exported/queried using API instead of the UI? Yes, that is absolutely the case. You can interface with any of the Kubecost functionality via API. We have a lot of teams that do so, and then use that to power their own dashboards or automation. And can the action as namespace turn down be configured using API? Yes, it can. And in fact, we're going to be adding into this next release the ability to configure actions via a YAML file as well. Do we have a plan to reduce Kubecost footprint?
So I think that's kind of like a microservices question, if you will. We're actually in the process of breaking out a lot of our functions and processes from a single pod deployment. So an example of like 2.0, depending on your deployment model, like single cluster is going to be a little bit different than multi-cluster. But in the multi-cluster scenario, you would actually be running a stateful set with the new aggregator component, and that cost analyzer pod would still exist. So we're actually adopting a more standard like microservices approach to our application.
Awesome. Does Kubecost have a plan to include SaaS application out of cluster cost for cost visualization? 100%. That is something we're looking at doing very soon. So yes, it is in our roadmap for first half of 2024. So you can expect to see more there very soon. Sean, you want to take this next one?
Yeah, can you toggle reconciled costs? It's useful to see the raw cost of your service as discounts and commit discounts can change, which will impact the build cost of a service. So that kind of talks back to that new feature we have that's basically going to kind of like learn your discounts over time. So like right now, you can't necessarily hide reconciled costs. We're always going to show them, but that 2-day window is going to get more accurate over time. If you're asking like, can we hide like the discounts and like only show like public on-demand rates? You can technically do that today just by not connecting your bill, essentially. So just basically always operating on on-demand rates.
Awesome. Sean, do you mind doing a quick demo of how you can do a CSV export here?
Yeah, sure. So that's actually really easy. From any view that supports it, this little 3-dot menu on the right-hand side will allow you to download the current information to a CSV or PDF. And these are actually both query parameters in our API. So if you want to programmatically download a CSV, you can do that via our API as well.
Yeah, and I would just add that if you go to the reports page, and if you save a report, it'll appear on this reports page, and then you're actually able to schedule this report such that this CSV or PDF will arrive in your inbox on a daily, weekly, or monthly cadence. So you don't even have to come into the Kubecost UI or APIs. You don't even have to pull the report. You can have it automatically pushed out to you. Awesome. And yes, Kubecost does support API calls to extract data, and you can use you can get the CSV straight from the API as well. Sean, you want to take the next one?
Yeah, I'm just reading through the list here. See, we're in discussions of using Kubecost open source. So Kubecost doesn't have an open source offering. We do have a free tier of a commercial available software. You might be talking about OpenCost, which is essentially an open source software project that we gave to the CNCF, I think 2 years ago at this point, going up for incubation. OpenCost essentially operates as a Prometheus metric emitter, so it makes you can scrape it with any tool that supports PromQL, and they can basically pull in those metrics and do whatever you want with them. At that point, that's purely for the cost analytics part. OpenCost doesn't offer like cost savings, availability, or governance at all today.
Awesome. Do you have any Grafana dashboard templates, and can we use it? We do have some nice Grafana integrations that I'm sure Sean can show. And also we definitely have some users who take our data and use that to power some Grafana dashboards.
Yeah, we do break out to Grafana for some like more histogram type information. So if you want to like analyze your like resource usage over time, we can do that. But then additionally, we've got customers that have like used our APIs to like build like custom cost dashboards as well in Grafana.
Awesome. Can we aggregate costs coming from AWS specific tag and Kubernetes workloads? So yes, I'm sure Sean can show. You can aggregate, you can filter and aggregate your Kubernetes and cloud costs by any custom label that you'd like.
Yep, that was part of the example we gave during our collections demo. So basically, I'm pulling in cloud costs via an owner label, but I can also do the same for Kubernetes. So I can find that I actually have a same owner label in Kubernetes. So I can very easily add those costs with the same label to that same collection.
Awesome. Okay, not a technical question. What would be your elevator pitch to incorporate this into an MLOps solution? I would say, MLOps in my experience, the costs for MLOps can get pretty out of control. I actually, my background is machine learning engineering, and I can say there were a number of times when I would deploy a model and it would train for a few days, and it would come back and have cost thousands and thousands of dollars. So I think some of the Kubecost predict functionality to help understand the cost of a workload or or training of a model before I actually deploy it, I think really resonates with me as a data scientist and former machine learning engineer. So hopefully that helps. Sean, you want to take what is the mechanism behind the scene for a namespace turn down? Is it deleting the namespace? I saw it was a cron-based action. I'm wondering how does it bring the workload back in the same state before turn down?
Yeah, I'm not actually familiar with how we do it behind the scenes. I believe we are deleting, and if it's a Helm workload, we're basically doing like a Helm uninstall. Say, feel free to correct me if I'm wrong.
Yeah, I believe we do a Helm uninstall, and we keep the things needed, the namespaces and the workloads needed to actually spin back up the workload. So it doesn't actually turn down the entire namespace. It does keep some remnants of functionality needed that we need to turn back on the workloads. So we can follow up with more details there if interested.
Yeah, we'll put that in our FAQ blog post.
Yeah, yeah.
Is it still recommended to have a Kubecost Prometheus installed? Can I use my own Prometheus? No issues. Kubecost. Yes. So we do. Our Helm chart does include Prometheus bundled with it. It is pared down. It's got some like relabel rules and some config to only care about the metrics that we do. So it is a bit of a pared down installation. We can technically work with your own existing Prometheus. That's typically only supported with an enterprise contract, though.
Awesome. Sean, you may know this better than me. Do you have the option to scale up and scale down if we run ML Kubernetes workflow and Airflow?
I think I'd probably need a bit more information to understand the use case there. I think it would depend on, excuse me, how the jobs are running and how they're submitted. We do have a number of customers that use Airflow and use us for cost accountability, but I'm not sure if they're using the automation to automatically scale the resources.
Yeah. Awesome. I see a question about, is namespace turned down an enterprise feature? This will be available excuse me, this will be available for free. However, it will have a scale limit of 250 cores.
Is there a benefit to installing Kubecost as an add-on via the AWS Marketplace once the latest version is available compared to deploying via Helm? There shouldn't be. The biggest thing with the add-ons is the availability of like the customizable options, because the add-ons are based on Helm anyway. It's essentially running the same chart. It's just a matter of what configuration items are available. I believe as of the latest publishing, which is that 104 version, they are available. So there should be no discernible difference. It kind of depends as an organization how you guys prefer to deploy those workloads.
Awesome. I see a question about working with AWS Fargate in 2.0. We still don't have the perfect solution there. We do monitor Fargate clusters, but we still have some improvements that we're going to be making later this year. So not full support for Fargate yet, but you are able to do some monitoring for Fargate clusters in Kubecost.
So Kai, you want to take the one on?
Yeah.
When we're expecting 2.1?
Yeah, we're actually expecting to launch Kubecost 2.1 any day now. So Kubecost 2.0 is our latest stable version, though I will call that out. 2.1 will have some additional features as well. And yeah, you can expect that any day. We're going to be iterating rapidly now on these new 2.0 features.
I see one specific to Amazon Managed Prometheus. So yes, we can work with AMP or GMP or Grafana Cloud, whatever Managed Prometheus offering you have. We have a number of posts within our documentation site that help you essentially configure for those different services as well.
Awesome. I see a question about the AWS cloud billing integration can be difficult to implement, especially if Terraform is used instead of CloudFormation. Do you have plans to enhance this process? Yeah, would love to dig in with you, Sergio, more on the challenges you're facing. But we do, take this seriously, and we want to, make our setup process, especially for cloud integration, as simple as possible. So definitely looking to invest more here.
Yeah, I know AWS released the data exports feature late last year, which is essentially a replacement for the standard cost and usage report. So we're currently consuming the legacy cost and usage report, which relies on the Athena integration and the CloudFormation template that they generate to configure that. So we are exploring what it would look like to support data exports, and if that would make essentially like the time to live quicker for our customers.
Awesome. Kubecost is an amazing solution, and certainly we need to utilize it for our FinOps purposes. Hopefully we'll see more down the road. Awesome. No, glad to hear that positive feedback. Let us know if you have any additional things we can add to support your FinOps use cases. So love to hear that.
Yeah, see a follow-up from Cristobal on the Prometheus question. Technically speaking, we best effort support for running your own Prometheus on the free version. If you're paying a customer, then obviously you get a bit more support with the success team there. And that's just because everyone's Prometheus environment can be a little bit different, and there's scale concerns there. But it should work, but it will require a bit more care.
Awesome. Sean, you want to take this last one here?
What is the main difference between you guys and Cast AI? Well, Cast AI is more of like a scaling solution, whereas we're more of a cost visibility solution. And they care more about like the CI/CD side of the equation, whereas we care more about the FinOps or the cost analysis side of the equation.
Yeah, well said. All right. I know we got a couple more coming in. We will be providing more documentation about what features is available in the enterprise-only version. At a high level, enterprise-only version gives you unlimited metric retention as opposed to just 15 days metric retention. It gives you unified multi-cluster view as opposed to single cluster view. It's going to give you unlimited cores as opposed to 250 cores, and it also gives you your standard enterprise functionality like Kubecost support from our dedicated FinOps professionals and Kubernetes experts, as well as RBAC, SSO, SAML, OIDC, etc. Great question, but we will provide more clarity there for sure.
So maybe I'll take this is the last question around feasibility to deploy via Terraform. So we do have customers today that are using basically the Helm provider for Terraform to deploy. You can certainly use Helm template to do the same. We've got customers that use like Kustomize or like a custom script essentially that will run like a Helm template and then make any modifications specific to their environment or their governance requirements. And I think that's probably a good stopping point for us.
Awesome. Yeah. Well, thank you all so much for the time. I know, I'm sure you have some more questions maybe that come into your head as we wrap up here, but feel free to send any questions our way to team@kubecost.com. We'd be more than happy to follow up. And as Dee mentioned, we're going to be compiling all of these questions and putting out a blog dedicated to just frequently asked questions about Kubecost 2.0. So really appreciate your time. Please feel free to follow up with any more questions or feedback about Kubecost. We'd love to hear from you.